All right, so I'm going to look at the 2024 Northern Hemisphere Methods exam, part two, exam two, multiple choice. Question one, the period and range of the function f of x equals root sine 2x minus pi on 2 minus root 3, respectively. Okay, I think the answer to this is C. Reason I think that is because the period of a sine graph is 2 pi divided by the dilation factor from the y-axis. So this is 2 pi on 2. So that's just pi for the period. And the range, well, the range is sort of the mean line plus or minus the amplitude. So the mean line, it's been shifted down root 3. So it's negative root 3 plus the amplitude. So that's root 3. So that's going to give us 0 for the maximum value. And the minimum value will be negative root 3 minus root 3, which is negative 2 root 3. So that's the minimum. So we must go from negative 2 root 3 to 0. And that's that option there, inclusive. For two independent events, A and B, it is known that the probability of A equals 0.6, the probability of A or B equals 0.92, the probability of B is equal to. I think the answer is A. And this is why I think that, because we have something in probability called the addition rule, which says that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, if you're wondering why that's the case, I think I'll just explain an example. I always use a deck of cards. If you want to know the probability of getting a king or a spade, you've got to add all the probability of getting a king plus the probability of getting a spade, but you have to subtract the intersection because there's one king of spades. So you would have counted the king of spades in the first set and in the second set. So you need to subtract the intersection, which is the king of spades, because you would have double counted that card, right? Anyway, so that's the rule. So we've got 0. We know the probability of A or B is 0.92. And we know that the probability of A is 0.6. And we don't know the probability of B. And we don't know the probability of A and B. So we know that if we subtract this from here, we get 0.32 equals the probability of B minus the probability of A and B. Yeah, I just had to work out what I was doing. So yes, just recall as well, it says the events are independent. So the probability of A and B, if you recall for independent events, is equal to the probability of A multiplied by the probability of B. So what we're going to do is we're going to be able to rewrite this as follows. So 0.32 equals the probability of B, which we don't know. Okay, minus the probability of A, which is 0.6, multiplied by the probability of B, which we don't know. Okay, and then this is why this question can be a little bit tricky. You got to take out the probability of B as a factor. See how we can take that out as a factor? And then you'll be left with 1 minus 0.6. And so if you divide everything now by this thing, which is 0.4, you'll get the probability of B equals 0.32 divided by, well, this thing here is 0.4. So what's that? So it's 32 on 40, which is 16 on 20, which is 8 on 10, which is 4/5. So I think that's the right answer. Maybe there's an easier way to do that. I'm not sure, but that's what I got. So question 3, the positive real numbers A, B, and C satisfy the equation log 5 of A plus log 5 of B equals 2 log 5 of C. It therefore must be true that. I think the answer is D. And this is why if we apply the log laws, and when you add logs, you can multiply what's inside. You can multiply these together. So we're going to get on the left-hand side, we're going to get log base 5 of A times B or AB. And that's going to equal a log base 5. Okay, another log law. You can move this, any coefficients of the log, into the power. So log base 5 of C to the C squared. Okay, if log 5 of AB equals log 5 of C squared, then you can just drop the logs because they must be equivalent. So AB must equal C squared. Hopefully you can see that. And then A equals C squared on B. So I think it's D. Question 4, a straight line passes through the positive x-intercept of the curve of the cubic, y equals x cubed minus x squared minus 2x, and also through its point of inflection. The gradient of this line is... So we're going to need our calculator for this, I think. So let's get our calculator out. If it would let me. It's not going to let me. Okay, we need to know what the x-intercept of this curve is. So set it equal to 0, right? So x cubed minus x squared minus 2x equals 0. Interactive, advanced, solve it. Okay, passes through the positive x-intercept of the curve and through its point of inflection. Okay, to find its point of inflection, to find the x value of its point of inflection, we need to let the double derivative equal 0. Interactive. Oh, you know what? Let's just sketch it. Let's just take this. We know that the x-intercept is at, positive 1 is at x equals 2. We go to here and then clear all, and then paste that there, and then sketch it. All right, the point of inflection is this middle point here. So if I zoom in, I reckon that's at I reckon that's at positive 1/2. But I can't be sure. So actually we do need to go and sketch it. Sorry, we need to go and solve the double derivative, I think. So interactive advanced calculation, we want to diff it. Yeah, I think if I change that to a 2, it takes the second derivative. Very good. Okay, now I need the second derivative to equal 0. You'll probably solve this in your head. Interactive, advanced, solve. Okay, you get 1/3. So yes, it was good that I checked that. So if I go back here, yeah, this point is at 1/3, I think. Okay, so basically we have the following situation. We know it needs to go through these 2 points. It needs to go through, I think the answer is this, by the way. I think it needs to go through the point 2, 0, and it needs to go through the point 1/3. Okay. F of 1/3. Well, essentially when you substitute 1/3 in here. So let's just go back to the calculator quickly. Substitute 1/3 into there. So maybe go back to the menu, main. Okay, you want to take this, but you want X. You want to go keyboard, math 3. You want X to be equal to 1/3. Negative 20 on 27. So what do we get? We get negative 20 on 27 is the y coordinate at that point, which sounds about right. It's negative because we saw that the point of inflection was below the x-axis. Okay, and then basically you just need to do y2 minus y1 over x2 minus x1. And so let's do that on the calculator because that would be a better idea. Okay, so you get your fraction out. Okay, y2 minus y1. So negative 20 divided by 27 minus 0 over 1/3 minus 0. So maybe the answer isn't 4/9. Let me think about that. I inputted it wrong, as you can see. That should have been, so it's, yeah, negative 20 on 27 minus 0 over 1/3 minus 2, which is 4/9. And it should make sense. The answer should be positive if you think about connecting those points together. Let me show you what I mean. Yeah, connecting this point here, which is the point of inflection, to this point, you should get a positive answer. So you should have been able to knock out D and E straight away just by looking at the graph. Okay, onwards we go. Question 5. When a biased coin is tossed, the probability of the coin landing on heads is 0.25. The coin is tossed 10 times and the number of heads is recorded. The probability that exactly X heads are recorded is... Okay, I think the answer to this is B. And the reason I think that is because I think it's a pretty straightforward binomial distribution question. So you've got to use the binomial formula, which is essentially what this is. Okay, so the first part says there's 10 choose X ways to get X heads when you flip a coin 10 times. Okay, the probability of success is 0.25. You want X successes. Yeah, you're going to get X successes because that's the 0.25 probability of getting heads. And then that must mean you had a 0.75 chance of getting however many other things there were, which is 10 minus X. So I think that is the correct answer. All the other ones are no good. Okay, question 6. The graph of y equals 10ax has an asymptote with the equation x equals pi on 6. A possible value of a is... Okay, with this question, I think you need to work smarter, not harder. So let me explain. I reckon the answer is C, 9. And let me explain why. If we get our calculator... Okay, and we're going to say the following. We know that there's an asymptote at x equals pi on 6. So I'm actually going to go to the graphing page. I'm going to put x equals, and then I'm going to do pi on 6. I'm going to tick that box, and then I'm going to graph it. And then the next thing I'm actually going to do is I'm going to go to sheet 2, go back to y equals. I don't have to go to sheet 2. I can stay here. And then what I'm going to do is I'm going to type in this, 10ax. A times x. And I'm going to graph that, and I'm going to do dynamic graphing. Okay, if a is 3, seems to be an asymptote at pi on 6, but that's not an option. So let's change these values. Let's change this to, if I go settings, I can just check all the options. If I press 4 and press OK, I think that crosses there. So I think that's no good. Let's do A being 6. That definitely crosses at 6. 9, as you can see, looks pretty good. It looks like it asymptotes along there. So if I zoom in, looks like we're getting an asymptote situation there. 10, let's check that. No, hopefully you can see that that looks like it crosses. And 12. The maximum needs to be larger. And clearly 12 crosses. So 9, let's just have a sanity check. 9, I think, looks good. Yep. Zoom in. Yeah, I think that looks pretty good. Okay, so I reckon the answer is 9. I'm sure there's an algebraic way to do that, but why do that if you don't have to? Question 7. The function f of x equals a cos b minus 1x plus b has a period of pi on 3 and a maximum value of 10. Given that b is positive, the minimum value of the function is... Okay, so remember that... and a maximum, given that b is greater than 0, the minimum value of the function is... Okay, remember that the minimum value of the function will be equal to the vertical shift, or your average line, or your mean line, minus your amplitude. So b minus a is the minimum, but we've got to work out what that is. It says that the period is pi on 3. So what we know is 2 pi divided by b minus 1 equals pi on 3. And so if we solve that, we're just going to get 6 pi. If I multiply the 3 to that side, equals pi b. If I expand this, pi b minus pi. So I'm going to get 7 pi equals pi b. So b equals 7. No, there's something wrong about that. Let me think. Okay, I think that actually looks good. So that's okay. So we know that the minimum is b minus a. We know you know, b is 7, but we also know that the maximum is b, which we know is 7 plus a, and that equals 10. So 10 equals 7 plus a, so a equals 3. So the minimum now must therefore be b minus a, which is 7 minus 3, which is 4. Yeah, so yeah, b is 4, I think. Okay, so minimum, let me just explain. The minimum equals b minus a. Well, b is 7, a is 3, so you get 4. Okay, should we sketch that? Let's do that. Let's see if that's right. Okay, let's. Oh no, I reckon it's right. Let's leave it at that. Yep, I'm sure that other answer was correct. Okay, question 8. When entering a zoo, visitors are asked how many times they have previously visited. The discrete random variable n with the probability distribution shown below can be used to model the number of times each visitor has previously visited. N from 0 to 4, probability that n equals n is 0.25, blah, blah, blah. Given that a visitor has previously visited the zoo, what is the probability that they have previously visited more than once? Okay, understanding this question can be quite tricky, I think. So let's have a think. So the probability, so it's conditional probability. So given that a visitor has previously visited the zoo, so that would mean that we're saying that n would be greater than or equal to 1 because they've previously visited, right? And we're saying, given that they've previously, what is the probability they've visited more than once? So more than once is strictly more than once, right? So n is greater than or equal to 2. So that's essentially what we're trying to work out. And so it'd be this, the probability n is greater than or equal to 2 and n is greater than or equal to 1 divided by the probability that n is greater than or equal to 1. Okay, and this is a conditional probability. As you can see, that's applying the conditional probability rule. And so, by the way, I think the answer is A, but let me explain why. So this top part, we need to I like to draw just a very small number line. N's greater than or equal to 2. So that's from here onwards. And n has to be greater than or equal to 1. Greater than or equal to 1. So that has to be all of this. Now the question is, where do they overlap? Where is the intersection? Okay, well, the intersection is just n greater than or equal to 2. So this is just the numerator just becomes n greater than or equal to 2. The probability that n is greater than or equal to 2 divided by the probability of n's greater than or equal to 1. Okay, what's the probability that n's greater than or equal to 2? Well, 0.25, 0.15, 0.05. So what's that? Adding them together, by the way. What's that? 0.4. So this is 0.45 on top, I think. Yes, that looks good. And then n greater than or equal to 1. Well, that's going to be point. We're just going to add this to the previous one. So it's going to be, what's that? We're just going to add, so it's going to be 0.75. Okay, and go to your calculator and see if you can work it out. 0.45 divided by 0.75. 0.45 divided by 0.75. It's 3/5, which is 0.6. Why did I get something different before? Let me have a think. Okay, I thought that when I did it previously, I got A as the answer, but given this logic, and I can't see why it's wrong, I reckon the answer is 0.6, so I've changed my mind. Let me know what you think. Okay, next question. Question 9. Let f of x equal 3x squared minus 2ax plus 6, where a is an element of real numbers. The set of values of a for which f of x is greater than 0 for all x is which of these? Okay, I think we need to graph this. Let me have a think. Yeah, so I'm not sure how to do this algebraically, but again, we might just need to use calculator functionality. So let's have a look. We need to basically put that onto a graph page, then we graph it with this variable a in there, and then we graph it dynamically. Okay, and if you actually have a play around here and you zoom out, you can see that you get this shape going on. So if you look at the answers as well, you got to look for a bit for clues. They all have root 3, root 2 on them. So what you can do is you go settings. Let me just delete those drawings. You go settings and you go 3. Change this to 3 root 2. Yeah, you get that. And so that's 3 root 2 there. So that's one solution. And so, yeah, you can sort of see that it moves in this shape. And there, sort of when it would touch it once there, it'd be when it's negative 3 root 2. So between negative 3 root 2 and positive 3 root 2, non-inclusive because it needs to be strictly greater than 0, you have, yeah, you have that whole function being greater than 0. So I reckon the answer is D. Okay, question 10, the graph of y equals f of x is shown below. Here it is. Find the value of k given that f of x is a probability density function. Okay, probability density function means that the area under the curve is equal to 1. So what we need to do is need to basically find the area of this in terms of k and then solve for k. And let it equal 1 and then solve for k. So what we can say first is maybe this is one way to do it. We know this is from negative k to k. So this has a length of 2k and has a height of k. So this sort of area here is 2k squared. Plus, okay, let's work out, we've got sort of two triangles going on here. So triangle is half times base times height. So let's just work out what this length is. The distance from here to here is 2, but the distance from there to there is k. So this distance is 2 minus k, I think. And the height is also k. So the area of this triangle is a half times the base, which is 2 minus k, times the height, which is k. But there's two of them because we've got this one over here. So we can get rid of the half because we're going to double it anyway. And all of that equals 1. And so let's just maybe simplify this a bit. 2k squared plus, let's get rid of that there. That's confusing. Plus 2k minus k squared equals 1. And let's use our calculator to solve that. What are we going to get? We're going to get, if I do 2k squared plus 2k minus k squared equals 1. Interactive, advanced, solve. Okay, I need to solve for k, not x. Okay, there we go. It's looking okay. How does that match with our answers? Given, find the value of k. You're going to have to take the positive one. Just based on the graph, because this is positive k here. Well, this is k, and it's to the right of 0. So this has to be root 2 minus 1. So I think the answer is A. All right, good stuff. Question 11. In a certain location, the number of hours, h, of daylight per day is modeled by this function, where t represents the day of the year. Note that t equals 1 represents the 1st of January. According to this model, during 1 year of 365 days, the number of days for which there are at least 11 hours of daylight is. So basically, we need this function. We need to find out for how many days this function is greater than 11. Now, I've tried to do this algebraically, like on the calculator, doing a solve this greater than 11. I can't for the life of me work out why it doesn't work. Even if I put in a domain, it gives me a general solution, which is frustrating. So I think, and how you're supposed to know how to do this in an exam is you have to graph it. I'm sure there is a way to do it by trying to solve it algebraically, but I just couldn't work it out. So you got to type this function in, 2 pi on 365 x minus 175. Okay, but we only want to graph it between 0 and 365. I reckon this question is quite tricky under time conditions. So if you graph that and then it doesn't appear, but I reckon it's there if we zoom out. Okay, so we're getting something like this. It's got a very long period. So we need to change our maximum x values. So let's make it say 400. Okay, so we get something like this. If we put in a vertical line, horizontal line rather, at 11, and graph that. Okay. We need it, if we just go back to the question, the number of days for which there are at least 11 hours of daylight. Okay, so what we can do is we can go analysis, G-solve, intersection. So that's, and I can hardly read it, it's 103.49 at least. So from 0 to 103.49. Okay, so let's write this down. From 0 to 103.49, you're getting 11 hours. And then the other intersection point is at 246.51. So what we could say is from 246.51 to 365, you're getting 11 hours of daylight. So that's 100 and, so let's work this out now. So that's 103.419 days. Let's write this. 103.49-ish days plus, all right. Oh, this should have been the other way around. I think you would agree. 365 minus that. 365 minus that. Okay, so then we can go back to a main page. If we go menu, main, okay, so 100, and this is where it's tricky because you need to take, because look at how close the answers are together. You can be off by a little bit. So 103.49 plus 365 minus 246.51 is 221.98. Okay, and now we've got to think, do we need to round up or do we need to round down? I think we need to round down because we don't quite get 222 days of full sunlight, of 11 hours of daylight. We get 221.98, which is cruelly close to 222, but I think you need to round down because you don't quite get that full day. Hopefully I haven't made a rounding error there. Let me know what you think. I'm sure that's right. Okay, Newton's method is used to estimate the x-intercepts of the function this with initial estimate of x naught equals 0. The estimate for x3 is closest to. Okay, the first thing you're going to want to do is you're going to want to define this in your calculator. You're going to go to log base e. If you use the natural log, it's easier. 2x plus 1 minus, okay, 4 minus x to the power of 512. Okay, we're going to highlight that. So we're going to interactive define. Let's define that as f of x. Okay, hopefully you can recall that you also need the derivative. So let's write f of x because that's part of Newton's method. Interactive define. Let's define the derivative as g of x. Okay. And I didn't do that properly, did I? Nope, I did not. So I just overwrote it. Okay, let's redo this. So if I do g of x or f of x, interactive advanced calculation, I want to diff that. I want to do that, and then I want to take this, and I want to highlight that, and I want to define that as g of x. Now, hopefully that's better. Okay, very good. That seems to work. Okay, now remember, Newton's method says you take your initial estimate minus your function evaluated at that estimate divided by the derivative evaluated at that estimate. So let's start with a 0 there. So we can write this answer minus f of answer divided by g of answer. And we're going to press enter. So our first estimate, so this would be x1, x2, x3. So I reckon the answer is C. So C is our answer, I think. All right, I suppose we have two continuous functions, f and g, with domain R. It is known that g of x is less than 0 for all x, and f dash of x equals g of x. Given that f of -1 equals 2 and f of 2 equals -1, what is the area enclosed by the graph of y equals g of x, the x-axis, and the lines x equals -1 and x equals 2? Okay. So what we could say is the following. Let's think. So we've got some curve. We've got g of x is less than 0. So something like this for all x. Given that f of -1 equals 2 and f of 2 equals -1, what is the area enclosed by the graph of y equals g of x? Okay, I've done this before, but I need to sort of write it down to make some sense of it. So from -1 to 2 of g of x dx, we know that, if we integrated that, we would get f of x. So we know that this is equal to f of x integrated between -1 and 2. So our answer is just going to be evaluating the definite integral, and they give us that information, right? F of 2 is -1. So let me be super clear. F of 2 minus f of -1. And so f of 2 is -1. And f of -1 is 2. So minus -2. That's confusing. Okay, -1 plus 2 is +1. So I reckon the answer is B. Given that, what is the area enclosed by the graph? Yeah, I think that looks okay. I just realized I did make an error, but it didn't affect the answer, I don't think. That was f of -1 is +2. It's +2. So I get, what do I get? Actually, maybe this is wrong. Maybe this is -3, but the area is below the x-axis. So in terms of an area, it would be +3. Let me just double check that. Maybe the answer is 3. Yeah, I reckon the answer is 3. So this should say -3, but then since g of x is entirely below the x-axis, to make it an area, you have to make it positive. So I reckon this should be -3 here, but then take the absolute value of that. So it should be +3 is your answer. So the finance team at a small technology company estimates that the production cost per item is given by the rule that and n is the number of items produced. The minimum cost per item is closest to n is an element of positive integers. Okay, that could be important. So I actually think I may have got this wrong the first time I did it. So let's try this out. You're going to want to define this in your calculator. So you're going to do 0.5. Let's do x squared minus 37.5 times x plus 1900 plus 1250 on x. Now, I think, let's define that firstly. Let's define that as c of x. Okay. I think, and potentially I could be wrong here, but if you take the derivative of this and let it equal 0, I want a calculation, differentiate that, let it equal 0. Interactive, advanced, solve. Okay, then you would need to take this and you need to sub it back in because that's the x value or that's the n value. Okay, yep. So remember, n has to be a positive integer. So that's not a positive integer. So we need to make it, what is it estimates that the production cost per item is given by this rule, the minimum cost per item. Okay, that's the x value at which it occurs, but we need to pick 38 or 39. I think we need to pick. Has to be an integer. Which one do we pick? Okay, let's just check both. Let's do C of 38. 0.89 we get, and then if we do C of 39, so we've got to choose between option, I think, between option D and E. Okay, let me think. Yeah, I don't know why I didn't think of this earlier. It has to be D because that's smaller than E. So producing 38 items is less expensive than producing 39 items. So they should produce 38. So I think the answer is D. That's a bit tricky because, oh yeah, it has to be a positive integer. Okay. Question 16. Okay, the values for two continuous functions f and g and their derivatives are given in the table below. What is the value of d dx of g of f of x? Okay, so let's think. The derivative of g of f of x, I prefer this notation. Let's do it like this. Okay, d dx of g of f of x. Okay, so you got to apply the chain rule because you got a composition of functions. I need 3 brackets there. Okay, so you got to take the derivative of the inside function. So it's f dash of x multiplied by g dash of f of x. Okay, and so now we just need to know f dash of 0. So f dash of 0 multiplied by g dash of f of 0. So that's going to give us f dash. F dash of 0 is -1 multiplied by g dash, or f of 0 is 2. So g dash of 2. So -1 times g dash of 2 is 3. So -1 times 3, which is -3. So I reckon the answer is A. Oh, also, you probably realized I missed question 14. I will put a link in the description for this question because I made a much nicer video than I can do with an explanation here. So you can go and watch that. Okay, suppose that 3 events, A, B, and C, suppose that for 3 events, A, B, and C, the probability of A given B equals 1, the probability of C given B equals the probability of C. Which of the following statements about A, B, and C must be true? Okay, we could say the following. We could say that we know a few things. We know that the probability of A given B equals the probability of A and B. This is just our conditional probability rule over the probability of B. And we know that that equals 1 because it says it equals 1 here. Okay. Okay, the probability of C given B equals the probability of C and B over the probability of B. But we know that equals the probability of C. Okay, from this top line, we can see that the probability of A and B divided by the probability of B equals 1. So therefore, the probability of A and B equals the probability of B. We also know this, the probability of C and B probability of C and B equals the probability, if you multiply the probability of B to the other side. So you'd get this, the probability of C and B equals the probability of C multiplied by the probability of B. Okay, so the probability of A, let's go through them, must be true. The probability of A equals 1. Is that true? No, I don't think so. Okay, C is a subset of B. Let me think. Yeah, I think the answer is D, because if we look at these rules, this is basically the rule for independent events. The probability of C and B equals the probability of C times the probability of B. So B and C are independent. And we can also say that the probability of A and B just equals the probability of B. So if you were to draw a Venn diagram, you'd have this. The probability of A and B is just the probability of B. So that must mean that A is a subset of B. So if this is A in here, and this larger group is B, well, the probability of A happening, the intersection is just the probability of B. Oh, geez, I'm struggling today. Let's see. This is the other way around. It says, I always get this the wrong way for some reason. B is a subset of A. So A is the larger group. B is a subset of that. So the probability of A and B, the intersection, is just the probability of B, which would make sense because where they intersect is just the probability of B because it's entirely contained within A. So I think the answer is D. I think that's quite a tricky one. That's very theoretical. Okay, question 18. Let f of x be cosine ax plus pi on 6, where a is greater than 0. There is a unique solution for f of x equals 1 and a unique solution to f of x equals -1. The minimum possible value of a is... Okay, again, I don't know how to do this algebraically, so I'm going to be as creative as I can. So let me just explain what I've done here. I've basically, on a graph page, I have written in the rule between 0 and 2 pi, and then if I graph that, I get something like that. I've also put in f of x equaling 1 and f of x equaling -1. For some reason, it's not letting me use a slider, and I don't know why, because that would be very helpful here. But there's only 5 options, so let's just think about those options. Let's just change this value of a to see where we get a unique solution. So if we do 1/12 and then graph that, zoom in a little bit. There we go. All right. Clearly, when a is 1/12, we're not getting any solutions because it's not going to hit the red line or the green line. So 1/12 is out of the picture. Let's do 5/12. Okay, that looks like it has one solution. This looks like it doesn't touch at 1. So I reckon that's no good. Let's do 5/6. Graph it. That looks like it has one solution. Doesn't look like it's touching the red line. So that's no good. All right, 11 on 12. That looks pretty good because it looks like it's touching the red line and the green line, but it's only touching the red line once and the green line once. So I reckon that looks pretty good. Let's check to make sure that 17 on 12 doesn't do anything weird. All right, this looks like it's got multiple times it touches the green line. So I reckon the answer is D. And you've got to be so good with your calculator, obviously, on these exams. So I reckon the answer is D. Okay, let's keep going. Let f be a continuous differentiable function. Part of the graph of f is shown below. The stationary points of f are at -1, f of -1, and 3, f of 3. The solution to the inequality, x squared minus x minus 2, multiplied by f dash of x, is greater than 0. Okay, I think this question is quite tricky. Basically, what we can do is we can factorize this and graph it. So let me explain what I mean. So if we factorize that, we're going to get, what multiplies to -2 and adds to -1. So what's that? 2 and 1. And it'd be, what would it be? It'd be -2 plus 1. So you're going to get x squared minus 2x. In fact, let's just do it more quickly. So basically, it's going to factorize to this. It's going to be x minus 2, x plus 1. Okay, and if I was to graph that, I would get at -2, I'd have an intercept. No, I wouldn't. At +2, I would have an intercept. So here somewhere, I'd have an intercept. And at -1, I'd have an intercept. And it's a positive quadratic, so it's going to look like that. And that's kind of bugging me how bad that is. Let's do that better job of that. Okay, now if we're to take that thing and multiply by the derivative. So basically the question is saying, where would you get answers that are greater than 0? Well, you need to, for something to be greater than 0, both parts need to be negative or both parts need to be positive. So the blue line here is positive, but the gradient of the black line is negative. So up to here is no good. What about between here and here? Well, clearly the gradient is negative here. The gradient of the black line is negative here, and then the blue line's still positive there, so that's no good. Okay, what about between here and here? Let's just break it up into sections, right? Between here and here. Well, the black line has a positive gradient, but the blue line is negative, so you'd still be getting a negative answer. Okay, what about from 0 to 3? And don't forget 2 is here. Actually, let's break it up even more. 2 is there, and then 3 is here. So between 0 and 2, the blue line's negative, and the black line's positive gradient. So that would also be negative. What about between 2 and 3? Well, between 2 and 3, the blue line is positive, and the black line has a positive gradient. So that's looking pretty good. And what about, anyway, after 3, the gradient of the black line is negative, and the blue line's positive. So that would give you a negative answer. So I think the answer is C. And I think that's quite a difficult question, but a nice question though. Okay, so C is our answer there. Okay, question 20. So now it's going to be tricky. Let f of x equal x squared by 1 minus x squared, and g be f of x minus a. Find all real values of a such that g of 0 is an absolute maximum value of g. Okay, I think the answer is E. But when I did it, I used Desmos. So doing this on the calculator, I think is very challenging. But we'll give it our best shot. So if I go to a main page, if I define it, x squared by 1 minus x squared, highlight that, interactive, define f of x. Okay, let's define g of x as f of x minus a. Interactive, define that as g of x. Okay, sometimes this doesn't work. So let's just check. Can you see how that has nothing to do with what I just typed in? So what you need to be careful of sometimes is go to variable manager. We've got 4 variables. Let's just delete them all. Go close, close. Let's try all of that again. x squared by 1 minus x squared. Interactive define as f of x. Okay, you define g of x as f of x minus a. I like that. Interactive define g of x. Okay, now check if g of x is what you want it to be. Okay, that looks a bit better. Okay, find all real values of a such that g of 0 is an absolute maximum value. Okay, what we want to do is now we want to go and sketch it. So go to a menu, go to graph and table, clear all this. F of x. Okay, let's do f of x minus a, or just g of x, right? And that's that, and we want to dynamic graph it. Of course it doesn't want to do it. What if I just try f of x minus a? Okay, okay, really, I only care about this graph between 0 and 1. So let's regraph it again. Invalid syntax. Of course there is. Zoom in. Zoom in. Why is that not graphing it? I don't know how you're supposed to do this in an exam. Okay, let's keep going ahead. So basically, it doesn't like when you put a domain when you've got a slider for some reason. So you can't do that. So what I'm going to suggest is you just put some vertical lines at 0 and 1. So you have to change it to that and then graph it there. Okay, so we're really just interested in this part here. And where did my slider go? There it is. Okay, if I change A, you can see that different things happen to the graph. And if you look at the options, negative root 2 on 2 seems to be a key point. So if I click on here, settings, negative root 2 divided by 2, is that going to do what I want it to do? Okay, so that seems to have a max, that seems to give us an absolute maximum value of the function between that domain. See how that's an absolute maximum there? If I go to the left, negative infinity. Okay, yes, because if you were to scroll down, you could imagine that that line would cross that green line at some point, and that would be the maximum value of the function. So anything less than negative root 2 on 2 is fine, and positive root 2 on 2. So let's do that. Positive root 2 on 2. Okay, that also seems to give us a absolute maximum value of the function between 0 and 1. Okay, so you can also check 1/2. What happens there? Yep. I think when it's 1/2, it's also got a maximum value of the function at 0. That's it almost, I don't know how anyone could do that under exam conditions. So I'm going to show you on Desmos. This is how I solved it, but yeah. All right, so here's Desmos. It's actually kind of cool. I shouldn't be so grumpy. It looks kind of cool if you graph it and change the value of A, you get all this sort of stuff going on just between 0 and 1, which is what I was trying to do on the calculator, but it wouldn't let me. Anyway, so yeah, we said between negative infinity to negative the square root of 2 on 2, we're going to get a maximum value of the function there. So you can see that that's a maximum value at 0, that x equals 0. Okay, if we just go back to having a slider, so anything less than that is also going to be fine, because what I was trying to explain before is, yeah, this is just going to move down, but you can see anything less than negative root 2 on 2 is going to give us a maximum value on the y-axis, which is at g of 0. Okay, the other thing we need to consider was when it's equal to like 1/2. So that point there is, oh, maybe I've changed my mind here because they're equal. Can you see that when A is 1/2, they have the same maximum value? So that wouldn't be an absolute maximum. Okay, actually, yeah, that is an absolute maximum, even though it's competing with this one and they're at the same height. So G of 1 also equals the same value. It's still considered the absolute maximum, I think. Okay, and then if we go to square root 2 on 2, the other one gets us to this position where that's a maximum. All right, if I make it a little bit larger than that though, so this is 0.707. So let's just make it a little bit larger than that. 0.707, 707. Okay, so that's sort of when we're getting, it's close to root 2 on 2. If we go larger than that, it starts to dip below and the maximum is no longer at x equaling 0. And so all of this is no good because the maximum's to the right now. So yeah, the answer is E. But how are you supposed to do that on your Casio class pad or on your TI Inspire under exam conditions is very challenging. So, but I don't know, it's kind of nice. It's kind of nice to look at it. Good luck. Hopefully that answered some of your questions.